Welcome to our session on process improvement and Six Sigma, presented by Dr. Microlearning. In this video, we'll walk through what Six Sigma is, how it works, the tools practitioners use, the benefits it delivers, common implementation challenges, and real-world case studies to bring the concepts to life. Stick with me, and you'll get a clear, practical view of how Six Sigma improves performance and quality. This slide outlines the structure of our talk, breaking it into 6 parts from an introduction to framework, tools, benefits, challenges, and case studies. Think of this as your roadmap for the session, so you know when we shift from theory to practical examples and learn how different concepts connect to form a cohesive improvement approach. Now we begin the first part, an introduction to Six Sigma, where we'll define core ideas and set the foundation for everything that follows. This section will clarify key principles, describe how the method developed, and explain why organizations adopt Six Sigma to reduce defects and meet customer expectations reliably. Six Sigma centers on reducing variation to achieve exceptional quality, aiming for near-zero defects through a data-driven approach and customer focus. It relies on structured problem-solving like DMEC and emphasizes evidence-based decisions rather than guesswork. In short, Six Sigma combines rigorous measurement with practical actions to align processes with customer needs and higher performance targets. Six Sigma started in manufacturing in the 1980 seconds and quickly spread across industries as its results became clear. Pioneers and business leaders helped popularize the approach, and over time it evolved from a strict quality control tool into a broader strategy for operational excellence and leadership-driven improvement. This slide highlights that history and the methodology's growing influence. Six Sigma matters because it delivers measurable improvements like cost savings, higher quality, standardized processes, and stronger competitive positioning. By cutting defects and inefficiencies, organizations can boost margins and customer satisfaction without necessarily increasing spending. Think of Six Sigma as a disciplined way to create consistent value across functions and projects. Part 2 introduces the Six Sigma framework and the structured methods teams use to drive improvement. In the upcoming slides, we'll explore DMAIC and alternative models like DMADV, plus the roles that keep initiatives on track. This section sets up the how-to part of Six Sigma, so you can see the practical steps behind successful projects. The DMEC methodology breaks problem-solving into 5 clear phases: define, measure, analyze, improve, and control. Start by clarifying the problem and customer needs. Gather meaningful data to baseline performance, analyze root causes, test targeted improvements, and finally lock in gains with control systems and documentation. DMAIC keeps teams focused and evidence-based from start to finish. For projects that design new products or processes, DMADV and DFSS provide a roadmap built around customer needs and innovation. These approaches emphasize designing quality into the solution from day one, using structured verification and customer alignment to avoid costly rework later. Together with DMAIC, they give teams options whether improving existing processes or creating new ones. Successful Six Sigma programs depend on clear roles, from white belts who support data gathering to green and black belts who lead projects, and master black belts and champions who provide strategic direction and resources. This role structure creates accountability and builds internal capability, ensuring projects are well executed and aligned with organizational priorities. Part 3 covers common tools and techniques used in Six Sigma, helping you move from concepts to hands-on problem-solving. We'll look at statistical tools, root cause methods like fishbone diagrams and 5 whys, plus flowcharts and process mapping that visualize work and expose bottlenecks. These are the practical instruments teams use every day. Statistical tools like control charts and histograms help teams visualize data distributions, monitor stability, and quantify performance capability. Control charts flag unusual variation over time so you can target corrective actions, while summary metrics such as mean and standard deviation make decisions objective. The visual and numeric insights together guide smarter, less subjective improvements. Root cause analysis techniques such as the fishbone diagram and the 5 whys help teams break complex problems into manageable causes and probe deeper than surface symptoms. The fishbone group's potential causes visually, while the 5 whys iteratively asks why until the root cause emerges. Combining these tools gives a holistic, layered approach to finding durable solutions. Process mapping and flowcharting provide a step-by-step visual of how work actually flows, making handoffs, duplication, and delays visible. These diagrams are invaluable for spotting bottlenecks and redesign opportunities, and they also improve communication by giving teams a shared picture of the process they are improving. Visual clarity speeds alignment and action. Part 4 focuses on the benefits organizations achieve by applying Six Sigma, from operational gains to better customer experiences. In this section, we'll see how streamlined processes, data-driven decisions, and cross-functional teamwork translate into measurable results like lower costs and higher quality, illustrated with images and examples to make the impact tangible. Six Sigma enhances operational efficiency by identifying bottlenecks, promoting data-driven decision-making, and fostering collaboration across functions. The images on this slide reinforce how teams use dashboards and cross-team meetings to align goals and speed up workflows. In practice, this means faster task completion, fewer handoffs, and more predictable outcomes for customers and stakeholders. Reducing costs and waste is a major payoff of Six Sigma, achieved by minimizing overproduction, defects, and unnecessary steps. Process optimizations cut material and operational expenses, while optimizing resources such as labor and equipment. The slide's production imagery illustrates how small changes on the line can lead to significant savings and less environmental impact. Improving product and service quality is central to Six Sigma, and it happens through defect reduction, greater customer satisfaction, and continuous incremental improvements. By measuring performance and iterating on processes, teams sustain quality gains and innovate in ways that build trust with customers. The graphics on this slide show how quality initiatives overlap with collaboration and structured methods. Part 5 discusses the challenges organizations often face when implementing Six Sigma and how to approach them realistically. Common barriers include resistance to change, training gaps, data limitations, and resource constraints. Acknowledging these issues up front helps teams plan mitigation strategies rather than being surprised during execution. Resistance to change often shows up as cultural barriers, leadership hesitation, or poor communication, slowing implementation and reducing effectiveness. Overcoming this requires clear messaging about benefits, visible leadership support, and engaging people early so they feel part of the solution rather than subject to it. Addressing concerns openly builds buy-in and momentum. A lack of proper training and shared understanding can create skill gaps, misapplication of tools, and resource constraints that undermine project outcomes. Investing in role-based education, mentoring from experienced practitioners, and accessible reference materials helps teams apply methods correctly and sustainably, turning initial challenges into long-term capability. Data collection and analysis limitations can compromise project findings if data are inconsistent, teams lack analytical tools, or the work becomes resource-intensive. Good Six Sigma relies on accurate, relevant data and the skills to interpret it. So planning for data quality, tooling, and time investments is essential to avoid flawed conclusions and ineffective solutions. Part 6 brings the ideas together with real-world case studies to show how Six Sigma delivers results in different sectors. We'll look at manufacturing, healthcare, and service examples that highlight defect reduction, cost savings, improved patient safety, and faster service delivery. These stories make the methods concrete and show typical outcomes you can expect. In manufacturing, Six Sigma projects often produce clear outcomes like fewer defects, substantial cost savings, and shorter cycle times, which together improve product quality and on-time delivery. The slide emphasizes how streamlined processes and targeted problem-solving reduce waste and warranty claims while raising throughput and customer satisfaction. In healthcare, Six Sigma has been applied to reduce medication errors, optimize patient flow, and allocate resources more effectively, improving safety and efficiency. The triangular model on the slide illustrates how leadership, skills, and communication combine to enhance performance, and the examples show measurable improvements in wait times and error reduction. The service sector example shows how DMATE can identify workflow inefficiencies, guide implementation of process changes, and deliver measurable outcomes such as a 25% reduction in service delivery time. By focusing on customer-facing processes and removing redundancies, organizations can significantly boost satisfaction and operational speed without major capital investments. Thanks for watching this overview of Six Sigma and its practical application. We covered key principles, frameworks like DMAIC and DMADV, essential tools, benefits, common implementation challenges, and case studies across industries. Use these insights to evaluate opportunities in your organization and start small, measure carefully, and scale improvements that show real value.